All right, so now that we've been over how to find a least common multiple / a least common denominator, the next thing is to shift back into sort of fraction land and look at how to sort of use those things to actually do some fraction addition. So what we're going to do, our kind of strategy here is use the LCD to scale up our fractions to the same denominator. Probably the easiest way to do this is to sort of do it just via an example. So let's get some numbers down and we'll sort of talk through it as we go. So let's say we were trying to sort of add, let's do something like 7/10 plus, 2/15 or something like that. So the first thing to notice is these are two different denominators. These are not the same, right? 10 and 15. So we're going to need an LCD for 10 and 15. These two numbers have some overlap if we just sort of quickly list a few multiples, right? 10, 20, kind of 30, 40, 15, 30, 45, 60. We see almost right away the multiples for 10 are easy to pick out, right? And so if we do 15 times 2, right, we would get 30. If we do 10 times 3, we would get 30. So our least common multiple, which acts as our least common denominator, is going to be 30. So what I need to do is I need to sort of rewrite both of these fractions with 30 as the denominator. So how do I do that? How do I get from 10 to 30 and 15 to 30? Well, what we're going to do is multiply. And so what we can do here is say, okay, well, how do I get, let's do 15 first, right? Well, 15 times 2 is going to be 30, right? And so kind of in the same way that in an equation, I can, multiply both sides. I can sort of multiply by any number I want as long as I do the same thing to both sides. So in a fraction, I can multiply by any number I want provided that I multiply both the top and the bottom by that same value, right? So if I'm going to multiply the bottom by 2, I also need to sort of scale up and multiply the top by the same thing. Really what I'm doing is I'm multiplying by 2/2, right? But any sort of fraction with matching numerators and denominators, this is just 1. 2/2 is 1, right? So this is going to become for us a sort of a new looking fraction, 4/30. But it's really the same value, right? Because we're just doing 2/15 times something that would be equivalent to 1. On the other side, well, we need to multiply by something different, right? Well, so how do I get from 10 to 30? What I'm going to multiply there is by 3. And then I'm going to match it and multiply by the exact same thing up top on the other side, right? So then 3 times 10 is 30. 3 times 7 is going to get me to 21. So what happens here is as I get a common denominator, both of these guys over 30, so that allows me to add them up. In this case, right, I'm going to add up my new numerators, 21 plus 4. This gets me to 25/30, and then that is going to reduce. That'll happen, right? 30 would be 5 times 6. 25 would be 5 times 5. So I can do a 5 out of each. And so my new final number, right, where do I end up here, is 5/6. So I kind of started with a 10 and a 15. We scaled up to 30, and then our final answer reduced down, excuse me, to 5/6. Let's do another example. Keep this math train rolling. How about, what could we do? Let's do something maybe where there's not really a lot of overlap between the numbers at all. I'll do a little double negative action too. How about negative 7/9 minus something like 3/4, for example. So 9 and 4, kind of a similar look, but they don't really have anything in common. First step, regardless, is we need an LCD. So let's look at 9 and 4. You know, we can list multiples here. We don't really need to go too far, right? 9 to 18 to 27 to 36. I mean, once I get to 9 times 4, I that's really as far as I know I'm going to need to go, right? 4 to 8 to 12 to 16, 20, not hitting anything. I guess we got to keep it going. 24, shift this up, 28, 32, and last but not least, finally getting us there is 36, right? So that was all the way to 4 times 9. So what's going to happen here, you know, if we did the breakdowns, we would see 9 would be 3 times 3, 4 would be 2 times 2. There's no overlapping factors here. So if there aren't going to be any overlapping factors, what that's going to mean for us math-wise is the least common denominator is just going to end up being the product of the two together. So what that means, right, for 3/4, I'm going to have to do this times 9, and then same sort of multiplication up top. On the 7, right, 7 over 9, so then that one needs to be multiplied by 4, and I'll do 7 times 4 here. So this becomes for us negative 28 over 36 minus 27 over 36. One thing to keep in mind, of course, right, 28 and 27 will subtract here, right, but 28 over 36, 27 over 36, they would both reduce, so you're going to be tempted to sort of see those numbers and say like, oh, well, I could divide this by 4, and oh, I could divide this by 9. Don't do that, right? The whole idea here is that you're trying to sort of get to a common denominator and then do the arithmetic. So this would look like kind of negative 28 minus 27 all over 36. Negative number minus another value, right? So what's going to happen here is this going to get us just a bigger negative value. Where are we going to end up? Negative 55, right? Yeah, because, you know, if this was 30, then this would be kind of 57, so 28. So this is going to be negative 55 all over 36, and no common factors there. 55 would be 5 times 11, 36, right? Would just be 4 times 9. It's really just 3s and 2s. So far, so good, I hope. Let's do one more example. Let's throw a couple of these variables in. Maybe we'll even do sort of 2 of those. I guess we'll see how long this video goes. I don't want to spend forever talking through all this stuff. Let's do some variables. So let's start with maybe something like 3a over 5 minus something like, I don't know, 7 over 10. So maybe we'll just do a little variable action on top. Just some regular kind of stuff on the bottom. LCD for 5 and 10. One of the things interesting here, right? So 5 divides evenly just like into 10, right? I mean, so, you know, kind of 10, 20, 30. But like 5 goes, right, 10, 15, 20. So like you can use 10, you know, if one of your denominators just goes into the other one, you could just use the bigger value here. Just use the 10 as your LCD. So that means you don't really need to change 7 over 10. You're just going to need to do 3a over 5 times 2 and 2. So that would leave us here with 6a over 10 minus 7 over 10. So this is one where we're going to do a subtraction up top, but or in some sense not going to really do any subtraction because these are unlike terms here, right? So 6a and sort of minus 7. One is a variable term, one is not. So these are unlike terms and they won't actually combine together. I sound a little disappointed. You know, this stuff happens. We're just gonna get what we get. There are no sort of good or bad answers here. These things just sort of are what they are. Let's throw some variables into the bottom. So let's do something like 8a over, I don't know, 15b. Let's add it to, how about 3b over something like 8a. So mixing up a little bit these different variables, sort of which is where. For our LCD, 15b and 8a, we're going to need a b and an a. We're going to need really a 15 and an 8. There's not going to be any overlap. If we do the breakdowns here, we'll do 8 and a, and then that's going to be, right, 4 and 2. So what we're going to see if we go down to the ends of each of these is there are just no common factors at all, right? So 3 times 5 times b, 2 times 2 times 2 times a. There's no common factors, so that means our LCD is just going to be the product of these two, 15b times 8a. What the heck is that going to be? 80 and 40, it's like 120. AB, that makes sense because it would be, right, 30 times 4. So to get both of these guys going, you're going to have to do this side times 15b, 15b. You're going to have to do the other one times 8a over 8a. What an example. So this is 8 times 8, so this is going to be 64, and then a times a would be a squared, right? This bottom term is, 120 with an a and a b, plus 3 times 15, 45, b times b, b squared, right? 120, a times b. And so what is going to happen for us here is we're just going to kind of get, a big old mess of numbers and variables, and not really anything is going to clean up out of here at all. So this is going to be, right, what happened here with the way that these sort of A's and B's were kind of out of sync is it, in some sense, sort of exaggerates and kind of piles on how far apart they are. You kind of need more A's on the left, but you kind of already have A's there. You need more B's on the right. You kind of already had B's there, so that really kind of, right, just sort of takes these guys farther and farther apart. And there's not going to be any numbers to cancel out of here. 64 is literally all 2's, and 45 is 3 and 5. So there's not going to be anything there to cancel out of the 120 that they all have. So you could end up with something kind of as messy as 64a squared plus 45b squared all over 128 times b. Kind of a worst case scenario, I guess. I mean, I don't want to sound dramatic by any means, but that kind of stuff can happen, and nothing to be too upset about, but that's where we can go. Otherwise, right, adding, subtracting without common denominator. There we go.